Okay, in last lecture, we saw Bresenham line drawing algorithm. Okay, and there we have seen how the decision parameter is derived, and based on decision parameter, we are going to select a particular pixel over there, and in this way, we need to uh, go on creating the next pixels, and whole line will get draw up to the last point. So, based on the same concept, basically, Bresenham circle drawing algorithm is derived. Okay, it also determines the next pixel of a screen. Okay, while drawing a circle, uh, and it again decides which pixel is nearby to the previous pixel. Based on that, the decision is made. Okay, you might have know that, or you learned that circle is having the symmetrical properties, right? So we are going to use that symmetrical property for the circle. I will revise what it means, symmetrical property. So we don't need to calculate all the pixels of all octets. Okay, we are going to divide a circle into octets and quadrants. Fine, you know there are 4 quadrants already. Okay, we are going to again divide that quadrant into two parts like that. So we need to find the pixel of only one octet, and rest we can conclude through this. Okay, just you need to calculate one octet only, pixels for one octet only, remember. So this is the circle. Okay, and so whole circle, this is the 45-degree angle, this is the radius for the circle. Okay, first point on the circle is x comma y. Reflection of this is, as you know, in case of reflection, left become right, right become left, right? It's like a mirror image only. So y, x, this is the first quadrant. You know that all the values are positive over here. Okay, go to the second quadrant. Here if you observe, one negative, one positive, right? So minus y, x, and this is the reflection for that, minus x, y. Okay, again third quadrant, both values are negative, right? Minus x minus y, minus y minus x. Similarly, in the fourth quadrant, first positive, next negative, right? Y minus x, x comma minus y. So this is what the symmetric property of a circle. Okay, so here we are going to find we are going to consider the quadrant one, and this octet we are going to consider. Let's see again with the help of example. So let's take the octet 2, which is in the quadrant 1. Okay, so this is octet 1. We have seen this first quadrant. Okay, we consider this much portion only, that is only first quadrant we considered over here, and it is again divided into 2. So this is octet 1, this is octet 2. Fine, so this particular octet we are going to consider. Okay, uh, both x and y value are positive, just I explained it. The initial pixel would be 0 comma y coordinate. Okay, or you can say 0 comma r as well, because this particular value is nothing but radius of a circle, right? That is indicated by r. Let's move ahead. Our circle is at some random point. Consider like with the help of rounder also, when you draw a circle, you take one random point, right? And from that random point, you draw your whole circle, right? So similar to that, we need to consider some random pixel p. Let's say the coordinates for the pixel are xk and yk. This is the pixel. Okay, now just imagine we are in a octet 2 only. Okay, though the figure looks like we have just zoomed it, or you can have a broad view of that particular octet 2. Fine, so this is xk, yk. Okay, now we need to find out our next pixel, right? Similar to line drawing algorithm. So whether you are going to move further, that is the forward, this is the north direction, so it is indicated by N, and this is the south direction, so it is indicated by S basically. Okay, So this is a particular expected what you can say perimeter for a circle. Okay, uh, or the points through which the circle need to pass, right? Mm. So x is definitely going to increment all the time, yes, because we are moving in a forward direction. What about y value? If you observe, y value is going to decrement, okay, as per our coordinate system, y value get decremented. So whether to plot the next pixel as this pixel or north pixel or a south pixel, that decision we are going to make over here. If you observe, this is the distance, right, from the north end pixel to the actual expected line, true line, right? So this is d1 length, right, which is actually greater than the radius value. Yes. What about this south pixel, which is less than the radius, right? Less than the radius if you observe from the origin, right? So d2 is basically a negative value, which is less. Let's understand it. So Bresenham circle drawing algorithm will help us to decide by calculating the difference between the radius and the coordinate of the next pixel. So every time x is going to increment, no doubt in it. Okay, whenever you are going to draw the next pixel, x is going to increment only, right? But what about y? If you observe from the p to n, the y value remains as it is, right? But if you move to the south direction, the y value get decremented. So you can't decide about y now, right? For that you need a initial decision parameter. Based on that we are going to decide it. So y will either get decremented or will be as it is. Okay, same concept as that of the line drawing algorithm. So here, can I say xk plus 1 is xk plus 1? Yes, definitely. Okay, so next that will be next consecutive pixel. Yk is minus 1 is represented over here is yk minus 1. Okay, so equation of circle, all of you aware about it. H and k are center for the circle. Okay, but if you put the uh, center at the origin, then value will be 0 for that. Yes, then x square plus y square is equal to r square, right? So function of the circle, we are writing the function, okay, of a circle equation. So it will be x square plus y square r square. We get it on the left side and represented it minus r square, like that. What about function of a circle at end point? Remember end point where y is not going to change here. Yes, and this is the s point where y is changing. Okay, so just for that point we are going to write the equation. That function is indicated by f of n, xk plus 1 square plus yk square minus r square. Okay, if you got fn, that is a function of n over here. Okay, will be positive because n is outside the circle. Fine, which is the value is greater than r square. Definitely, if this value is greater than r square and if you subtract some r square through that, definitely you will get the positive value only. You are not going to get a negative value over here. Okay, so say consider 10 is the radius for that n, and say 8 is the radius for the r square. R is 8, consider. Okay, so 10 square minus 8 square, so definitely it goes to positive value only. So like that, we will have a function for s as well, but now it is negative. Why it is negative? Because the point is falling inside the circle, right, or a pixel is falling inside the circle. That's why it is negative point. Okay, so whatever value you are going to get over here is the less as compared to r value, right? So that's the reason it is negative. Okay, so the value of function s is already negative. So can I say, while deciding the decision parameter, tk is equal to fn plus fs? Yes, no need to subtract because fs is going to give already a negative value, right? if you remember, in case of line algorithm, we did it like d1 minus d2, but here there is no need of, because it is already returning a negative value. So here either we will get a positive value for decay or a negative value for decay, right? So if decay is less than 0, right, so that means the negative fs is bigger than the positive fn. Okay, that implies the n is closer. So we are going to keep the y value as it is, just increment the x value. Fine, and that pixel is nothing but n. Okay, reverse is the case when decay is greater than 0. That means the positive fn is bigger, s is more closer to the as fs is smaller, right? So we'll select the s as our next pixel. Okay, fine, let's move ahead. Now we are going to calculate the decay value, which I already indicated. It is Fn plus Fs. We have both equations with us now. Fn is already there, Fs is already there. Just put both equations in the equation decay. Okay, xk plus 1 square plus yk square minus r square. Okay, only yk. Remember, this is Fn and this is Fs where yk minus 1 is there. Fine, so just replace xk plus 1 is equal to xk plus 1 and yk minus 1 is equal to yk minus 1 currently here. Okay, because this is for s, right? There is no minus 1 for in case of n. So just replace the value and get the equation. You will get this value over here. Okay, you can calculate it. This is the equation 1, okay, which we derived from the fn and fs. Now we need to find the next decision parameter. Yes, every time we need to go on finding the next decision parameter. Based on that, we are going to decide which pixel is closer, okay, or which pixel is having the less distance from the expected line, right? So decay plus 1, here just replace k by k plus 1, that's it. Okay, so here decay plus 1 will be xk plus 1. See here, see this equation, equation 1. Okay, so just k is replaced by k plus 1 over here, plus 1 square plus yk. Now k is replaced by k plus 1. Okay, so yk plus 1 is nothing but yk minus 1 in our case, right? But we are just replacing k with k plus 1, so I am writing it like this. We are going to replace it later on, plus yk here, here it is yk plus 1 minus 1. Okay, minus 2r square, keep it as it is. Yes, now replacing xk plus 1 is definitely x is going to increment, no doubt in it. But what about y? Yes, we can't decide about y right now. Okay, it depends on whether the decay is less than 0 or it is greater than 0. Depending on that decision parameter, we are going to replace it. So just what we need to do, decay plus 1 minus decay. Okay, this second equation is formed. Okay, uh, okay, this is the second equation. I think I forgot to give the number, but this is the second equation where I am pointing over here. And see, I wrote it 2xk plus 2 square yk plus 1 square yk plus 1 minus 1 square minus 2 r square. And this is the equation 1. What about decay? This is the equation 1. Okay, so just go on calculating. You will get which value? Yes, this is the value you will get for xk plus 2 yk plus 1 square minus 2 yk plus 1 minus 2 yk square plus 2 yk. These are just a simple calculation. Okay, addition, multiplication, subtraction. Okay, after you will calculate all these things, you know how to calculate a plus b square. You are well aware about it. A square plus 2ab plus b square. Based on that, you just go on calculating, you will get this value definitely. Fine. If decay is less than 0, then what about y value? Y value will remain as it is. It is not going to change. So this value now you need to yk plus 1 is nothing but yk over here. So this is 2yk square minus 2yk minus 2yk square plus 2yk plus 6. Okay, just cancel out the parameters over here. It gives you dk plus 4xk plus 6. This cancel out with this cancel out with this, and you will get this value. Okay, so whenever d is less than 0, okay, you will get d is equal to d plus 4x plus 6. Okay, then now if d is greater than 0 or dk is greater than 0, then you need to put yk plus 1 is equal to yk minus 1. Fine, just go on putting the value over here. See here, so put the values: dk plus 4xk plus 2, now yk minus 1 over here, minus 2yk minus 1. See how I wrote it: minus 2yk square plus 2yk plus 6. Okay, calculate it. Some values or some terms get cancelled with each other. Okay, and whatever remaining terms are there, you will get this value over here whenever the d is greater than 0. Fine, in that case you are going to move to the south pixel, that is the downward pixel, you can say. Now to find, so this is about, we found out about d is less than 0, d greater than 0, but at initial decision parameter is not, we didn't get it, right? So how to find it, initial decision parameter? So we consider the initial value is 0 comma y. As you remember that y is nothing but r. Yes, I told you in that case as well, while explaining the diagram. So put in dk, this equation is already with you. Okay, this decay equation, put the initial value. X you need to put 0 over here, so 1 square is nothing but 1 only, so here you will get the 2 value. What about y? Replace it with r. Okay, so r square plus r minus 1 square minus 2r square. Okay, so after calculating this thing, see here I calculated it, you will get 3 minus 2r is the first decision parameter. Okay, sometimes the mathematics is asked in the exam, so how you derive the decision parameters and all. So these are the basic formulas which you are going to use. Okay, and based on that we calculated the values, nothing complicated over here. It is just a simple mathematics. Okay, we'll go ahead. Now we'll see the algorithm quickly. As I told you, if you remember, you just need to find out pixel for one octet only. And with the help of symmetric property of a circle, we are going to plot the remaining values. Okay, just with the help of reflection, that's it. Okay, so initial value is x is 0, y is equal to r, right? So d is equal to 3 minus 2r, that is the initial decision parameter. Yes, now some termination condition is required, right? So what is the termination condition? When x will meet to the y value, then definitely the circle will end, right? Mm. So x should be less than or equal to y, right? X should be less than or equal to y, it should not go beyond that. Okay, so here if you observe y x x y, this is x and y c, just center. Every time you need to add the center, that's it, whatever center you are going to take. If this value is 0, it is simply y x x y minus x y minus y x minus y minus x minus x minus y. Yes, one more thing, you can write this sequence in any order, doesn't matter at all. Okay, sequence doesn't matter, right? So you can write it in any order. Suppose if you feel comfortable, you can go ahead like x y minus x y minus x minus y, x comma minus y, like this. Then reverse the sequence. First you need to take the y comma x, then minus y comma x, y comma minus x, minus y minus x, like that. Eight values should be there because it's a octet. Okay, because it's octet, that's the reason. So whenever the d is less than 0, Yes, every time which value is going to increment? X is every time going to increment. D is less than 0, D is equal to D plus 4x plus 6. Just now we calculated this decision parameter. Yes, we saw it. Else, D is equal to D plus 4x minus y plus 10. Okay, now decrement the y, now decrement y, and else will be ended here. Only in else part, if you observe, I incremented the y value. Okay, and finally increment the x value. That's the end of while. Okay, stop there itself. Now we will see a simple example. I will share wait just a minute. I will share a screen whiteboard with you. Okay, so that you will understand with the help of example. We'll see a simple example over here. Okay, now we'll have x. Okay, text I will take x, like we did for the line algorithm, same way. But yes, take a decision parameter here. Take D or P, anything you can have, and finally there is a plot. Okay, plot. Now what is x value? Okay, x initial x, if you remember, the value is 0. Okay, we are going to take input as a center of a circle and radius of a circle. Say here, for example, I took 10 as a radius over here. Okay, so first decision parameter you are going to decide. So I will take the another text box here. So for the decision parameter, D is equal to 3 minus 2 into R. This is the first decision parameter. R is 10 in our case, so is equal to 3 minus 2 into 10, that is 20, is equal to minus 17 value you got over here. So what is the first value over here? We'll go ahead. Yes, minus 17 is the value. This is the first decision parameter. What about plot value? 0 comma 10 is the plot value. Okay, now first decision parameter you got it as a negative, that is nothing but D is less than 0. So every time x is going to increment. What about y value? Y value will remain as it is. Okay, then we'll calculate the next decision parameter over here. Here I will put it. Yes, D1, say for example D0 is done, initial decision parameter. Okay, so now D1 is equal to D plus 4x. I hope you remember the formula. 4 into x, okay, plus 6. Okay, 4x plus 6. So what is the value over here? D is previous D is minus 17. Okay, that is D0 you can say, plus 4x, initial value of x is 0, so 4 into 0 over here, and plus 6, which value you got over here? Minus 17 plus 6, that is, yes, minus 11 you will get over here, right? Minus 11 value. Yes, now we will put that value over here, minus 11. Plot will be now 1 comma 10. Okay, go ahead. X going to increment. What about y value? Same, not going to increment, right? Now again calculate the next value, say D2. Same formula again, because it is again a negative value, right? So should I write directly minus 11? Okay, previous value for the D, that is D1, that is minus 11, plus 4 into what was the previous value of x? It is 1. Okay, plus 6. How much value you will get here? Minus 1, right? Minus 1 you will get here. Put that value over here, minus 1. Okay, have a plot over here. 2 comma 10. Yes. What about next value? X is going to increment definitely. What about y value? Remain as it is. See, if you observe, because the decision parameter, whatever we got here, is a negative value. Let's go ahead with the D3 value now. D3 is equal to -1. Yes, plus 4 into what was the previous value now? 2. And what about plus 6 is equal to, okay, 13, I think. Yes, correct. It is 13. Fine. So now we got the positive value. If you observe, yes. Then plot. You will have a plot over here. Yes. Now increment x. What about y? Y value will get decrement. We are moving downward, if you remember, right? Now plot I will put here 4 comma 9. Okay, 4 comma 9. Then now calculate D4 value. Okay, next decision parameter is equal to, now the formula will get changed because the whatever value you got here is a positive value. 4 into 4 into, okay, x plus y, and here it is plus 10. Okay, this is the value, right? So d, previous d is 13 plus 4 into x plus y. What is x plus y value here? Previous x is 3, y is uh, previous x is 3, and 10, right? Is it 4? Just a minute, 4, sorry, it's x minus y, sorry. Okay, uh, x minus y. So x is 3, y is 10, 3 minus 10 is 7. Okay, 7 4s are 28, so minus 28 over here, minus 28 plus 10. What is the value over here? 23 minus 28. Here you will get the minus 5 value. Okay, again you got the negative decision parameter over here. So which value is going to increment? Only x. What about y? Will be as it is. We'll find the next decision parameter over here. Then here it is 5 comma 9. Yes, let's find out next decision parameter here. D5 is equal to d plus, okay, formula already I wrote it, d plus 4x plus 6. Okay, so minus 5 plus 4 into previous x value. What is the previous x value? That is 4. Then plus 6. Yes, how much is the value? Is equal to 4 4s are 16 plus 6 22 minus 5. Here you will get a value is uh, here value whatever you get is 17, but now it's a positive value. Yes, it's a positive value now. We'll put it 17. Next, go ahead. Positive value increment x, decrement y. We'll calculate it. Okay, 6 comma 8, d6. Calculate d6 is equal to positive value, right? So 17 plus 4 into x minus y. What is the x minus y value? 5 minus 9. That gives you minus 4. and into 4, that is minus 16 over here. Okay, plus 10 you are having here. Yes, so here it will be 1 11 1 1, that is 11. Okay, so put that value here, 1 1. Go ahead, next. Okay, again you got the positive value, increment it, decrement it. Okay, now if you find it out, x is equal to y. See here, x is equal to y, reached condition get satisfied, so we need to stop here itself. Okay, in this way the Bresenham circle will get drawn. Fine, I hope you understood. So this is the simple example I took it so that you can understand it properly. Okay, now I will show you quickly a demonstration for the Bresenham circle algorithm. Fine, again I will share the screen so that, yes, quickly run it. See the same algorithm. I wrote it, whatever I explained. Okay, 3 minus 2 r, x is less than or equal to y, d is less than 0, then else d is greater than 0, then decrement y, increment x. Simple algorithm. Okay, run it quickly. Okay, so you need to provide some center over here. Okay, so I used as x1 as a center, value is say for 50, I am giving another 50 for example, and radius is say 25 for example. Okay, and this is the B circle. See the circle get drawn. If you want different colors for each octet, you can give a different color as well. One more circle we will draw at say for example 150 position. I will give you another 150. Okay, and say radius is 50 for example. Okay, we'll draw one more circle like this. Fine, so in this way Bresenham circle works properly. That is about Bresenham circle.